So I'd like to talk about spray foam insulation. It is pretty popular and it's really effective at getting really high R values. And I just want to say though that I am kind of turned off by it. Um, it it comes with a very significant environmental cost, and there are a lot of problems that can be associated with it. Okay, so we'll talk about that, but setting the stage a little bit here. The way you do this, it's like painting a house. Okay? You put on these like small layers and kind of build it up, and it expands as you spray this stuff on. Okay? What we're doing is we're putting plastic inside the walls. Okay? And depending on whether you're using open cell foam or closed cell foam, that literally is plastic, meaning it's vapor impermeable. Okay? That is a double-edged sword. Okay, that could be good in certain circumstances. It can be very bad in other circumstances. Okay? The reason people like this is it has really high R values per inch. Okay, so if you need to achieve a certain R value per the energy code, and you only want to use 2x4 walls or something like that, you can get that R value in a 2x4 wall with spray foam insulation. Okay, specifically closed cell. Closed cell foam, we'll talk about the difference between closed cell and open cell here in a minute, but closed cell foam, you can get up to R7 per inch, which is incredible. Okay, so if you have, if you spray it in a 2x4 wall, that's R25 essentially in a 2x4 wall, which is pretty incredible. Okay. Now, closed cell foam, like I said before, is an air barrier and a vapor barrier. Okay, so the fact that it's an air barrier could be a very good thing. The fact that it's a vapor barrier could be a good thing in your climate. Okay, if you're in a really cold climate, it could be a very bad thing in other climates. Okay, and one problem, or at least one thing that I see being a huge problem in the future, is that people are using closed cell foam to completely seal up the rafters and ceiling in a building and create an unvented attic. Okay, and they sell this pretty hard, and there are benefits to an unvented attic that we'll get into in a little bit here, but it could be problematic. And again, I don't want to get too deep into this right now, but I just want to say people are using closed cell foam, and especially flat roof, modern looking buildings are really, really hot right now. Everybody has to have these. And since there's no attic space, they're all cathedral ceilings, they're having to completely foam everything in order to get the R value in the ceiling. Okay, there's no attic, there's just 12 inches of rafter depth or something like that. Okay, so they're spray foaming the entire thing. It's completely unvented. I think it's kind of a ticking time bomb, but anyway, again, I don't want to get too deep into that. One kind of huge benefit of spray foam is it really locks together the plywood and the framing. Okay, and you can see this chart. I'm not entirely sure what this means, but it substantially increases the racking load here. Okay, I'm interpreting that as like the shear force on the plywood. Okay, so it really locks those materials together. Okay, same thing like on a roof assembly. You foam the whole thing, it really locks everything together. Okay, floor system as well. Problem with that though is, let's say you want to come back and renovate years down the road, everything's completely locked together. Okay, you're not pulling a piece of insulation, fiberglass insulation, out of the way to fish a wire through or something like that. You're like chopping this stuff out of the way. Okay, and then in cases I've seen where this stuff goes bad, I mean, it's a nightmare. I mean, taking this stuff apart, you're literally like carving it off of the framing with a Sawzall, okay, or a utility knife, okay. So double-edged sword as well, okay. It's great, fills everything, locks everything together, but hopefully you never have to come back and do anything on that wall. It's really good at these weird nooks and crannies and odd size spaces. The way it expands into spaces and completely fills them, it's great. It's a really great way to fill cavities and seal up otherwise difficult to insulate places. Okay. So open cell and closed cell, there's two different options that you have. Okay, if you want to spray foam your house, they'll ask you, do you want open cell? Do you want closed cell? Okay. With open cell foam, water is going to be the solvent for that foam. Okay. And with closed cell, it's going to be some sort of proprietary chemical depending on what kind of material you purchase. Okay. And so this is the biggest difference here, and I guess it's kind of like duh, but with open cell foam, the cells are open. Okay. Air and vapor can pass through those cells, can pass through that foam. With closed cell foam, the cells are closed. Air and vapor is unable to pass through those cells. Okay, again, that could be good, that could be bad. Open cell is lighter, it's cushier, it's softer, there's more air in that open cell foam. Okay, the closed cell is really dense, and if you watch that this old house video, they're knocking on the closed cell foam, and it's hard. Okay, it's like a Lego in the wall. Okay, it's really dense. Open cell, one of the reasons people might want to use open cell is it expands a lot more. Okay, so if you're in some weird place and you want to make sure that it's going to completely fill that area, use open cell foam. It's going to expand up to 3 inches per application. Okay, closed cell foam is going to expand a lot less, 1 inch each time. Okay, if you're trying to fill a 2x4 wall, maybe you don't want to use open cell foam. You spray it, it expands 3 inches, and that's it. And it's got a lot less R value. Closed cell, you spray it on, it expands a little bit, and you can kind of build it up and achieve the desired R value. Okay, and I also have a video that you can watch showing spray foam getting installed. This open cell foam is going to be R4 per inch, R6 up to R7 for the closed cell foam. Okay. Now, getting into the problem with it, I already kind of mentioned this, but hydrofluorocarbons, the HFCs, are the blowing agents for this foam. Okay, those are the products that are, it's a gas that's released as this stuff is created, as it's expanding, getting blown out of the gun, or getting turned into sheets. Hydrofluorocarbons are released. Okay, hydrofluorocarbons are 1,000 times worse than carbon dioxide at trapping heat in the atmosphere. Okay, so this is the big question here. Okay, we're doing this to address an environmental concern. Let's use foam to increase the energy efficiency of the house, but the environmental investment, and this is the thing that people don't always consider, the embodied carbon, how much energy went into this thing, how many pollutants are we releasing once this thing is created in our attempt to address energy savings, okay? And with a lot of these foams, XPS foam, spray foam insulation, the payback, and this is a good chart here, but the payback is how many years of operating this house and saving energy costs. How many years do we have to run this house before we get a return on our investment? Okay, and this chart I just kind of pulled off. This has 120 years for XPF foam. Okay, I've seen other studies that were a little more specific where depending on where your energy is produced, that's going to determine how long that payback is. Okay, so if you're in Kentucky and you build a house and you spray foam the entire thing, it's going to take about 25 years to offset the environmental cost of that spray foam because they're burning coal to make all their electricity, and coal is kind of like the dirtiest fuel that we have. Okay? If you're on the West Coast, let's say you're in Seattle and you build a house and you spray foam the entire thing and you're all happy and everything's great and you can plug your Teslas into the garage and everything. Okay, it's going to take 350 years to realize that investment because all of the electricity that we're generating is from renewable sources. It's from solar and wind, okay? So it doesn't really matter if we're offsetting electrical use, if we're saving money on energy costs, because all of our energy is coming from the sun or the wind, okay? So it's a lot more complicated than we want to believe, okay? So I don't want to dwell on this too much, but they are moving away from these hydrofluorocarbons, which is good, okay? Another thing that I don't want to make too big a deal out of it, but there are cases that if this isn't done right, it can cause health problems in the house, okay? And I guess this picture kind of says a lot, okay? This guy's in like a full Tyvek suit with a respirator putting this stuff on, okay? It's not the most eco-groovy stuff. Supposedly, once it's cured and everything's all said and done, it's totally inert and you don't have to worry about it. But there are some things that have to happen, okay? The mix has to be right, okay? The temperature, the ambient temperature has to be within a certain range. So if things don't come together, okay, because you are mixing two different chemicals together, okay? There's a part A and a part B, and they're moving through these hoses, and they're mixing together and getting sprayed out. And then as they connect, they react, and they expand into this foam. So if things don't go perfectly, they could not cure correctly, and you could have off-gassing problems. And there are certainly cases that you can look up and see where there were kind of some botched foam jobs and people were getting sick in the house and it just stunk. And what did they have to do? They had to tear open the walls and carve out all the foam and start over again. Okay, so it can certainly be problematic. I've heard of spray foam insulation being referred to as solid gasoline. Okay, and it is like there's a lot of oil in this stuff and it's really combustible. Okay, it goes up real nice. Okay, and then when it's burning, it's emitting tons of toxic pollutants that are making everybody sick that are trying to fight the fires. Okay, so as long as it doesn't burn, great. Once it burns, it's kind of a catastrophe. And then this is the thing that I'm foreseeing being a big problem, and I'm hearing talk of this at like the conferences I go to. It's great. Okay, we're going to make this unvented attic, and we don't need to vent it because we're totally sealing everything up with foam, and we're using closed cell foam, and it's a vapor barrier and it's an air barrier. Okay, so there's no potential for air to migrate in there and get trapped, and there's no potential for condensation because no air or vapor can move through this material. Okay, that's great when it starts out that way. But what seems to be happening, and this is just a fact about spray foam, its performance will degrade over time. Okay, you're going to lose some of that stated R value because it degrades. And this is the biggest thing that I don't think people are fully grasping yet, is it's going to pull away from the framing. Little cracks are going to appear. Okay, it's going to shrink a little bit. Things are going to move around. Things are going to open up a little bit. Air is going to find its way in. And instead of like my Victorian, where everything's wide open and there's air blowing around all over the place and it can dry out, with the foam pulling away, it's these tiny little cracks, these tiny little pathways that air and water find their way into. And just think about like warm air making its way in and slowly moving through this material and then cooling as it goes through and leaving little droplets of water behind. Okay? And then, since it's such a tiny little pathway, it's difficult for it to get out. And then we're going up against some material like OSB that is vapor closed. It can't dry to the outside either. Okay? This stuff is going to deteriorate really, really rapidly. And we're seeing this especially along like ridges. I've heard stories, people referring to this stuff as like mulch, okay? The ridge being mulch. And you can see all this rot here. This is from, so this side of the roof was over the garage and it had ventilation, okay? It wasn't insulated. There was air moving around underneath the sheathing, drying it out. This had foam all the way up to the deck. And there were problems with it, and it's totally rotten, and it's totally shot. Okay? And then I guess the biggest thing that I would just say about foam insulation is it's super expensive. Okay? I don't know that you're really gonna realize your investment back. It's up to 4 times the price of fiberglass. And like I said before, you can achieve great results with fiberglass if you do it correctly, okay? Foam's really easy, okay? It's fast, it's easy, it's effective, okay? It's kind of an easy way to solve problems, okay? But there are a lot more problems that go along with this stuff.